For a long time, the prevailing view about our brains was, well, pretty static. The thinking went, after a certain age, early childhood, the fundamental structure was basically set.
Right, like concrete. It wasn't really going to change much.
Exactly. But the material we've been digging into, it paints a dramatically different picture, and frankly, a much more exciting one.
Absolutely. This deep dive is all about neural plasticity. That incredible ability of the brain to change, adapt, and even sort of rewire itself.
And not just when you're young, right?
No, that's the key thing. Throughout your entire life.
So we're going to explore what the research reveals about how this plasticity actually works, how it's shaped not just by genes, but by our experiences, the environments we're in.
And critically, our relationships, those connections we make with other people.
And our goal here is to pull out the most important insights, those nuggets you need to know about how you can tap into and stimulate this lifelong capacity for learning and change.
Sounds good. Where should we start?
Okay, let's unpack this shift in thinking. The sources, they point back to some early studies that really cemented that fixed brain idea.
The classic stuff.
Yeah, like imprinting and baby geese, where they latch onto the first moving thing they see.
Or those studies on cats, showing how vital early visual input was for their sight to develop properly.
Right, and these studies, they gave this really strong impression that early experiences just permanently wired the brain, locked it in.
And what's so fascinating looking back is how applying those findings, from less complex animal brains directly to the incredibly intricate human brain, can be misleading.
How so?
The research now makes it really clear that genetic expression isn't some fixed blueprint. It's actually influenced by experiences throughout life. Our brains are just far more flexible than those early studies suggested.
So while yes, there are definitely sensitive periods, like times of really intense growth early on, the idea that things learned or experienced then are somehow indelible or, permanently fixed, that's really being challenged by modern neuroscience.
Right. Massively challenged. The material highlights that these brain-building processes, they continue well past childhood. Things like neurogenesis.
That's the birth of new brain cells.
Exactly. And neuroplasticity, the changing of connections between existing cells. Plus epigenetic changes, where experiences influence how genes in the brain are turned on or off. It keeps happening.
And this isn't just about, say, bouncing back after an injury, although that is a type of plasticity.
True.
The key insight now seems to be that the adult brain isn't just less plastic. It's more about balancing flexibility for new learning with the stability we need.
Which makes sense, right? Different life stages need different things. Even how we process information changes over time. That's it. Another aspect of this ongoing reorganization.
So what's driving this change?
Well, a core mechanism we see discussed is use-dependent plasticity. It's basically the principle that the connections in the actual organization of your brain cells change based on how you use them, how you adapt.
Okay, use it and it changes.
Pretty much. And this is where the examples from the sources get really vivid. Think about the sensory and motor parts of the brain.
Okay.
They physically reorganize based on use. Like when you learn a new skill, or even after an injury forces you to adapt.
You mean like actual physical changes?
Yes. One study mentioned shows how violinists have a larger area in their brain maps dedicated to the fingers of their left hand.
Ah, the hand doing all the complex work on the fingerboard.
Precisely. Compared to people who don't play string instruments, Braille readers show similar changes in the touch areas of their brain. Very specific adaptations.
And the famous London cab drivers, I remember reading about that.
Yeah, the research found they have a larger hippocampus that's a brain area crucial for memory and navigation.
Because their job requires constantly storing and recalling all those complex routes.
Exactly. Their brains literally grow, or at least reorganize, to meet that demand. More visual spatial information processing needed, so that area adapts.
What's remarkable, as the sources point out, is that even these sensory and motor areas, which people once thought were quite fixed after development,
most hardwired bits,
they show extensive plasticity, which really suggests that the higher level parts, the executive and association areas of the cortex,
the thinking and planning parts.
Yeah, the parts involved in complex thought, decision-making, the ones defined by their adaptability, they're likely even more plastic, constantly forming new connections.
And get this, there's this fascinating detail. Studies show a continual increase in white matter volume that's like the brain's wiring cables and parts of the frontal and temporal lobes in men, continuing well into their 50s.
Wow, into their 50s. That's much later than I would have thought.
Right, so the powerful takeaway here, for you listening is that your ability to learn new things, master new skills, adapt at any age isn't just some potential you might have.
It's actively happening.
Yes. It's actively happening because your brain is constantly reshaping itself based on what you ask it to do. Use it, and it changes.
Okay, so the potential is there. Now, the material does hint at some exciting future possibilities, right? Things still maybe in the research phase.
Yeah, definitely. It touches on potentially boosting plasticity biochemically down the line. Things like using BDNF.
That's brain-derived neurotrophic factor, like a brain fertilizer.
Sort of, yeah. Or manipulating NMDA receptors, those tiny doorways on brain cells essential for learning. Maybe even using compounds like decycloserine or regenerative approaches like stem cells. Very futuristic stuff.
But that's the future. What about now?
Well, what's really empowering right now is the strong emphasis in the sources that we already possess, powerful tools to enhance plasticity, just through our everyday lives and interactions.
Okay, so how do we do that?
This brings us to the potent impact of enriched environments and stimulating lives. So it's something researchers have known for decades, really, meaning being in an environment that's rich with novelty, challenge, social interaction. It has this profound positive effect on the brain over the long term.
Are there examples?
Oh yeah, compelling evidence from animal studies.
Yeah.
You take rats, raise them in complex environments, cages with toys, ladders, other rats to interact with.
Compared to just a plain cage.
Exactly. The ones in the complex environment develop brains with thicker cortices and hippocampi, more connections between cells, longer branches on their neurons, basically more complex, robust brains across the board.
That makes intuitive sense.
And here's a really surprising detail from that research. Even malnourished rats, if they're raised in those rich environments, ended up with heavier brains than well-fed rats who were just stuck in boring cages.
Wow. That really highlights the sheer power of the environment, doesn't it? Overcoming even biological deficits to some extent.
It really does. And connecting this to human lives, one study looked at Korean children adopted into U.S. families. Now, many of these kids experienced early malnutrition and deprivation. But the stimulating environment and good nutrition they received in the U.S. seemed to help counteract those early deficits.
How so?
Their height, weight, and even IQ scores ended up being comparable to American averages. It suggests environmental enrichment can have a massive impact.
Any other human evidence?
There's another finding mentioned in older adults. It showed that the length of dendrites, those branching parts of brain cells that receive signals,
right,
in a language area called Wernicke's area, correlated with how many years of education they had. More stimulation, it seems, was linked to more complex brain structures, even later in life.
This sounds like it builds directly into the cognitive reserve idea.
Precisely. It's the hypothesis that living a mentally and socially stimulating life basically builds up more neural material, stronger connections, maybe more efficient networks, perhaps even more cells in some areas. It acts like a buffer.
A buffer against what?
Against the effects of aging, or diseases like Alzheimer's, or even injury. The more reserve you build up through life, the more capacity your brain has to withstand these challenges and still function well later on.
So like having more brain power banked away.
In a way, yes. And research supports this. Higher levels of education, more demanding occupations. These are associated with brains that age better and are more resistant to dementia.
Is there specific evidence, say, related to Alzheimer's?
Yeah, one striking example cited is based on autopsy studies. They found older individuals who had more education could have more of the physical signs of Alzheimer's, those amyloid plaques and neurofibrillary tangles.
The hallmarks of the disease.
Right. They could have more of that pathology in their brains after death, yet have performed just as well on cognitive tests while alive as people with less education and less pathology.
So their cognitive reserve was actually protecting their function despite the underlying disease process.
That's the interpretation. Their brains had found ways to compensate.
And it's not just about preventing decline, is it? The material suggests maybe even reversing some changes.
Yeah, that's another hopeful point. It suggests that age-related intellectual changes can often be halted or even reversed in many older adults simply by increasing their engagement. More stimulating environments, more social activities.
Which leads to thinking about something like psychotherapy through this lens.
Absolutely. You could see therapy as a kind of powerful, enriched environment, couldn't you? Specifically tailored for emotional and social learning.
The challenges, the insights, the support.
Exactly. They likely contribute to building more complex and, importantly, more resilient brain circuits related to emotion regulation and relationships.
Okay, so enriched environments are key. What else influences plasticity? The sources mentioned arousal, right? Finding a sweet spot.
Yes, this is crucial. The research highlights that one thing consistently done across successful psychotherapies is managing a client's stress or arousal levels.
And that's not just about making someone feel comfortable.
No, it's actually fundamental for enhancing the brain's ability to change. To learn something new, your brain needs to be alert and motivated. You need a certain level of arousal.
If you're completely relaxed, half asleep,
There's no real impetus to learn or adapt, right? Your brain's like, everything's fine, no need to change.
but the opposite is also true, and this seems really important if you're too stressed.
Yeah, if you're in that high alert fight or flight mode, that actually shuts down the kind of complex learning and change that involves the cortex, the thinking part of the brain.
Why is that?
Your brain basically shifts resources.
Yeah.
It's focused on immediate survival, not on building new pathways for nuanced understanding or emotional processing.
Yeah.
Survival first, learning later.
So there's a balance needed.
Exactly. The brain needs that sweet spot, somewhere between total calm and extreme danger. This optimal state for learning is often described physiologically, but psychologically it feels like interest, engagement, curiosity. Maybe slightly challenged, but not overwhelmed.
This reminds me of that classic concept mentioned in the material, the inverted U learning curve.
Yerkes-Dodson Law, yeah. Performance. And that includes learning is best at a medium level of arousal. It drops off when arousal is either too low or too high.
And this isn't just a psychological idea.
No, it's deeply rooted in brain biology. Stress hormones like cortisol and norepinephrine and key players in learning like NMDA receptors and BDNF, they also seem to operate on this inverted U principle. Moderate levels support learning and plasticity.
While very high or very low levels get in the way.
Precisely. And the material adds a specific cautionary point about cortisol. While a little bit is necessary, maybe even helpful.
High levels are bad news.
Very bad news for plasticity. High levels actually inhibit neuroplasticity, especially in the hippocampus, that key memory area. And in extreme chronic cases, high cortisol can even damage or kill brain cells there. It really underscores the cost of chronic high stress.
Okay, so the practical takeaway for you, the listener, is really understanding this balance. Finding that sweet spot of engagement, challenged enough to be interested, but not so stressed you shut down, that seems essential for effective learning and adaptation in, well, any area of life.
Absolutely. Whether it's learning a skill, studying for an exam, or engaging in personal growth or therapy, managing arousal is key.
Okay, so we've covered enriched environments, use-dependent plasticity, arousal. What about relationships? The sources really emphasize how social our brains are.
Hugely important. Relationships have this incredible power to heal and shape us. The material delves into something called attachment plasticity.
Attachment, meaning those early bonds with caregivers.
Yes, and while those early patterns are undeniably influential, really foundational,
They set a kind of template.
they do.
Yeah.
But the research strongly challenges the idea that they are permanently hardwired and cannot change later in life. That's another example of moving beyond the fixed brain idea.
So even if early attachment wasn't ideal, it can change.
Yes, we see evidence of this. Studies show considerable shifts, fluctuations in people's attachment styles or schemas over time and across different relationships.
And that's not just like measurement error.
The sources argue it's likely not just error. It reflects the brain's ongoing capacity for change, specifically based on new, significant social experiences.
So the crucial insight here, especially for people who might have insecure attachment patterns from early life,
Is that these patterns are absolutely subject to change. They can be modified as a result of positive, corrective social input later on.
and this provides a really powerful way to view therapy, doesn't it?
It really does. Psychotherapy can function as a kind of carefully guided relationship. It helps regulate anxiety and fear, creating a safe space.
Where more secure ways of relating, more secure internal models or schemas can actually develop.
Right. The research explains how consciously processing difficult life events, often within that safe relationship context, correlates with better outcomes. Things like achieving secure attachment, having more flexible emotional responses.
And this is linked to brain changes.
It's linked to the integration of different brain circuits. A healing relationship provides the safety and support needed for that integration to achieve what's sometimes called earned autonomy or earned security.
Meaning you build a secure attachment style through effort and positive experience, even if your start wasn't ideal.
Exactly. It's earned.
Broadening this out then, the material emphasizes how much the success of therapy beyond just the specific techniques used.
Is tied to the quality of the therapeutic relationship itself. Things like the therapist's empathy, the client's trust and belief in the process, the installation of hope. These aren't just fuzzy concepts.
They have real impact, which connects directly to the placebo effect, right?
Right.
Or what the sources also call the meaning response.
Yes, it's a perfect example, a potent demonstration of how the mind, guided by social interaction and expectation, can directly influence the brain and the body.
So the effect comes from the meaning a patient assigns to a treatment.
Yeah, shaped by their expectations, their beliefs, and importantly, the social context. Like the doctor's or therapist's confidence and belief, their perceived empathy.
The sources mention that the historical perspective, too.
Right, that shamans and healers have leveraged the power of suggestion and positive expectation for millennia. It's ancient wisdom in a way.
And it contrasts this with how modern Western medicine sometimes views placebos maybe as just a nuisance variable to control for in drug trials.
Potentially missing the profound impact the healer's role and the therapeutic relationship itself can have on outcomes.
What's the neurobiology behind this placebo or meaning response? How does belief translate into physical change?
It's fascinating. It seems to involve top-down modulation, the higher thinking parts of the brain, like the prefrontal cortex.
Executive control center.
Kind of, yeah. It uses social experiences, positive feelings, optimism to influence lower brain areas. It activates the brain's natural reward pathways.
Involving chemicals like
Dopamine, serotonin, endorphins, the same systems involved in pleasure, motivation, and positive social connection. It's like the brain is rewarding the belief.
And what about negative states like fear or pain?
Importantly, the amygdala, a key area for processing fear and pain, seems to be inhibited or dampened by these positive emotions and expectations generated by the meaning response.
Are there specific examples of this in action?
Yeah, some compelling ones cited. There's the study where women anticipating mild discomfort showed reduced brain activity in threat response areas, like the amygdala, when they were holding their spouse's hand. And the effect was even stronger if they reported feeling the relationship was more supportive. Social connection literally calmed the fear circuits.
Wow.
Or another finding how synchronized physiological arousal, like heart rate patterns, between a client and therapist correlated with more positive interaction outcomes in therapy sessions, a sign of attunement.
Even in neurological conditions?
Yes, even in Parkinson's disease. Just anticipating a reward, believing something positive might happen, can stimulate dopamine release in the brain and temporarily improve motor symptoms for some patients. Belief influencing brain chemistry.
That's incredible.
And the striking irony the material points out. It's how intentionally leveraging this placebo or meaning response in medical treatment, the sources list suggestions like increasing doctor-patient contact time, aligning beliefs about the treatment, showing genuine empathy and caring, really listening, using appropriate physical touch.
Wait, that sounds familiar.
Exactly. It looks remarkably similar to the so-called non-specific factors that are often highlighted as crucial to effective psychotherapy and traditional healing practices across cultures.
So they're not non-specific at all?
Not really. There are specific ways that social interaction, empathy, and positive expectation leverage the brain's innate capacity for healing and change. They're active ingredients.
Okay. So bringing this all together then, if we had to summarize the central message from this deep dive,
I'd say it's that your brain is incredibly wonderfully plastic throughout your entire life.
it is absolutely not set in stone after childhood. That old idea is just wrong.
Definitely wrong. And we've seen the major forces influencing this lifelong capacity, how you actively use your brain, the challenges, the learning.
Use-dependent plasticity.
Right. Then there's the richness and stimulation of your environment.
Those enriched environments building cognitive reserve.
Exactly. Finding that sweet spot of challenge and arousal for optimal learning.
Not too stressed, not too bored.
And perhaps most powerfully, the depth and quality of your relationships, their ability to shape and even heal the brain.
Which offers really a tremendous message of hope, doesn't it?
I think so. Insecure attachment patterns from early life, not necessarily permanent. They can change with positive social input later on.
Cognitive decline, not an inevitable fate for everyone. Stimulating lives build that powerful reserve.
And healing relationships, whether in therapy or life, they tap directly into the brain's own capacity for repair and adaptation.
Psychotherapy comes up again as a beautiful illustration of these principles in action.
It really does. It works, in part, by creating what's been called a safe emergency.
A safe emergency.
Yeah, a challenging but secure environment designed to modulate arousal, effectively hitting that sweet spot for learning and processing difficult experiences.
And it's also fundamentally a potent, enriched social environment.
Absolutely.
Oh.
One that actively uses these very principles of enhancing plasticity and leveraging the brain's capacity for change, potentially influencing brain chemistry, dopamine, serotonin, endorphins in ways that support growth and well-being.
So, considering the immense power our social connections and positive expectations that meaning response we talked about have on brain function and our overall health, here's maybe a final thought to leave you with.
Okay.
Given everything we've discussed, how might you, in your daily interactions, in your relationships, consciously choose to become an architect? Not just of your own brain's ongoing capacity for change, but potentially through connection, empathy, and support, an architect of the plasticity and well-being of those around you, too.